Hello students, today we shall understand about voltage multipliers and that too about a voltage tripler and a quadrupler. So shown here is a circuit diagram of a voltage tripler and a quadrupler. So both of this can be made to work from this particular circuit. You can see here the given input signal and then the capacitors C1 here, then D1 here, C2 here, D2 here, C3 here, D3 here, C4 here, D4 here. So there are totally 4 diodes and 4 capacitors connected in a particular way so that it works as a voltage quadrupler this circuit itself will work as a voltage tripler. Now we shall try to understand how it works. Okay. So first we shall think about the positive half cycle of an input signal. Okay. Now during the positive half cycle, you know, this end become positive, this end become negative. Now consider the diode, whether it is working now. Yes, the diode D1 will obviously work in this particular situation. So you know that when this diode works, obviously this capacitor will get charged. So now how the capacitor will get charged? It will be charged like positive here and negative here. So the capacitor will get charged in this diode through this diode D1, and at that time you are not getting any output, but then the capacitor will get charged. Okay. Now we should understand what will be the voltage of the capacitor when it gets charged, maximum voltage of the capacitor. And you know that it is Vm, but still we can find out using Kirchhoff's voltage equation. That is now you know that so we can say that the total sum of the all the voltage sources can be written it to be equal to 0. So here, you know, conventionally we can say this voltage source as this voltage source V in as positive, then this is negative positive, so this has become opposite polarity. So this is minus Vc. So if I take the capacitor's charge as Vc, and then there is no other voltage source, or there is no voltage drop, so I can say this is as equal to 0. So in this particular branch or in this particular loop, we can say that the V input voltage minus Vc should be equal to 0. But then what is the maximum voltage of the V in? That is Vm, right? So I can write Vm minus Vc equal to 0. So I can now write Vc as equal to Vm. So what will be the voltage of this capacitor? Capacitor will get charged maximum to Vm. So I am writing it as Vm. Okay. Now coming to the next half cycle, that is negative half cycle. So we shall think about the next half cycle. So in the positive half cycle, the capacitor got charged as Vm. Now in the negative half cycle, coming next negative half cycle, you know that this diode will not conduct. So but then we know that this diode D2 is going to conduct, because P2 this P side and N negative to this N side. So obviously this diode D2 will conduct, as well as the D4 also can conduct. But then so now we can consider about the this particular branch where the current is flowing through the D2. So I can say that the current is flowing in this particular loop during this negative half cycle. So when the current flows in this loop, again I can consider writing Kirchhoff's voltage equation to find out what is the charge of this what is the voltage of this capacitor, how much it will get charged. Okay. So now you can see when the current is flowing through this diode D2, there is a voltage source here which provides the current, but now you have to think one more source is there, because capacitor is now charged to Vm voltage. So that also will act as a battery, as you know, right? So I can write the Kirchhoff's voltage equation for this particular loop. Now if you again consider Kirchhoff's voltage equation, and I am writing this V in as Vm, because maximum voltage of this V in is Vm, right? So then I can write it as, it is negative conventionally speaking, you know that it is polarity. If we think that is positive, it has reversed, right? So I can now write in the first negative half cycle, or in the second time I can write this Vm as negative Vm. Okay, so this is negative Vm. Now what about this? This was already negative, minus Vm, because capacitor is now charged to Vm, and positive negative we take as negative polarity, so that is minus Vm. Here also it is positive negative, so we take it as minus Vm, and then you come to the capacitor. Now capacitor will get charged like this is positive and this is negative, right? Because positive here, this cell is positive according to this voltage source. This side is positive, so capacitor will be charged positively here, and this is negative. So if I take this conventionally, I can say this is negative positive, which means that this is plus Vc, capacitor's charge, and this whole thing is equal to 0. Okay, I hope you understood about the polarity. This is positive negative, so I take it as negative Vm. Again positive negative, I take it as negative Vm. Here comes, when it comes to here, it becomes negative positive in this series, so I can say this as plus Vc. So now I take it as we got the equation like this. Now what is Vc? Vc equal to 2 times Vm. Okay, so that is, now I got the voltage of this capacitor, that is 2 Vm. So till much this much we understood, right? So this got charged to Vm, and this in the negative half cycle, this got charged to 2 Vm. Now coming to the next positive half cycle. Okay, so coming to the next positive half cycle, I can write like this. You know that this diode T1 is going to conduct, as well as this, at that time this and this gets charged. So that means it is easy for the D3 also to get charged, because negative to negative, and all these are, this is also negatively charged. So this means this D3 will get charged. Okay, now this D3 will be open during this time. So now in this half cycle, when D3 is open, I can say that the current is flowing through in this loop, in this direction. Okay, in this wider loop. Okay, so now again writing the Kirchhoff's voltage equation and finding to how much this capacitor will get charged. Okay, now you should understand that this capacitor is already charged to Vm. This capacitor is voltage drop across it is 2 Vm. Now both of them as well as the voltage source will act as actually voltage sources. So this voltage source, then this capacitor, and this capacitor will act as battery. So now writing the Kirchhoff's voltage equation for this particular loop. Again conventionally how will I write negative positive as plus Vm. Okay, then positive negative, this voltage across this capacitor as minus Vm. Now coming to this voltage, we don't know. So now what is the polarity of that particular capacitor? So that I can write this as negative, and this becomes positive. Okay, this is connected, this positive connected to this, so this become positive, and this side it is negative. So now so conventionally how can I write that capacitor's voltage as? Again minus Vc, then coming to here, and this is minus plus 2 Vm, that is negative positive, so that is plus 2 Vm. Now what is Vc? Vc is equal to this Vm, and this Vm will get cancelled. So what is this Vc? Vc will be equal to 2 times Vm. So how much voltage will develop across this voltage, which this capacitor, that is also 2 Vm. Okay, so this much has happened by the second positive half cycle. Now let me rub this. Okay, so now coming to the next half cycle, that is next negative half cycle, that is one complete cycle was over, then one positive cycle was over, then coming to the negative half cycle. Now what happens? And during this cycle, I can understand that this diode D1 is going to conduct, because this is also charged to negative, and this side is positive. So it is obvious that this diode D4 will get forward biased. Now this diode will get forward biased. So now think about the polarity of this capacitor. Capacitor will get charged like this is positive as this negative. Okay. Now again writing the Kirchhoff's voltage equation in order to find the voltage across this capacitor. So now which loop you have to consider? This bigger loop. Okay. Now considering this big loop, now you tell me what you can easily write what is the voltage, Kirchhoff's voltage equation. So here again I can write from starting from here, this time this minus Vm, okay, and this is also minus Vm, okay. Now coming to this is also minus 2 Vm, okay. Now coming to here, this is negative positive, so that is plus Vm. We see, we don't know what is the voltage, and then this is also plus 2 Vm, that is the voltage across this one, and this should be equal to 0. Now think this is minus 2, this will get cancelled, and now what is this is minus Vm, and so what is Vc? Vc is equal to 2 Vm. So this voltage will which this capacitor will also get charged such that the voltage across it is 2 Vm. Now you see, if you take the voltage across these two junctions, you can see you will get a voltage as equal to 2 Vm plus 2 Vm, and that is 4 Vm. So now you understood that is a voltage quadrupler. If you take the voltage across these two junctions, you are going to get if the input voltage maxima is Vm, and the output you are going to get as 4 times Vm. Now if you take the voltage across these 2 points, that is along these 2 points, you will get the voltage as Vm plus 2 Vm, and that is actually equal to 3 times Vm. So when you give an input signal with the maximum voltage Vm to a circuit like this, from these 2 points you will get the 3 times that voltage maxima, and across these two junctions you will get the 4 times the maximum voltage. So this side will act as a voltage tripler, and from this side it will act as a voltage quadrupler. So now I hope you understood this working of a voltage tripler and a quadrupler. Thank you very much.